Okay, so we're going to do the y-intercept. So we're going to plug in x equals 0. So for the x-intercept, you plug in y equals 0. For the y-intercept, you plug in x equals 0. And you do the same thing. Now we're solving for y. All right, so now we're going to have 0 minus 2. What's 0 minus 2? What's negative 2 squared? 4. So we're going to have 4 plus y squared is equal to 1. So Carter, what would I do next to solve for y? Just think like an 8th grader. Subtract the 4. Just get y by itself. Okay? So subtract the 4. You're going to get y squared is equal to negative 3. Is that right?
Plus or minus negative 3. Square root of -3.
Yeah, that doesn't work.
It doesn't come out.
Plugged in a 0 for x, right?
Yeah.
So we get 4 plus y squared is equal to 1. Y squared is equal to negative 3. Take square root of both sides. No, our math's right. I'm just making sure here. And then what we get is we get plus or minus, but you have a what? You have a negative. Okay, you have a negative. So it's plus or minus what? Does anybody know what you do when you do the square root of a negative? It'd be remembering all the way back to 9th grade. You haven't done it probably for, actually you probably did it in pre-calc A and B. Yeah, you did it. You guys have had pre-calc A and B, right? Yeah, you'd have done it here. What's the square root of a negative? It's imaginary, so it's I. Okay, but here's the good part. Until we get to that section, for right now, if you have an imaginary, just throw it out. So you just get to throw it out. Okay? All right, so we let x equal 0 to get the y-intercept. So we have two x-intercepts, 3, 0, and 1, 0. Plot any additional points if needed. All right, let's test for symmetry now. Okay, let's test for symmetry. I'm still a little baffled here. Oh, I know why. Never mind. I was freaking out a little bit. I was like, why do I not have, and then I thought about it for a second. Duh. That's why I was sitting there stumbling, not you guys. All right, symmetry. You need to pay attention to this. Last year, this was the most missed question on my first test. Test for symmetry. Okay, I had like half the class get it right and half the class get it wrong. To test for symmetry, you are only going to have to test for 3 things. You got to test for x-axis. Leave yourself a little room. Y-axis. And origin. You are required to know the test for all 3. All right, now just think about it. X-axis. If you want to be symmetric about the x-axis, so here's the y-axis. Here's the x-axis. Everybody look up here. So if I want to test for x-axis symmetry, I want to be able to flip my graph and a point match up exactly. So which point are you doing the opposite of? The y. Can you remember that? So it's the y we make negative. So it's x negative y is the test. So what I'm going to do is take my equation and replace it. And this is how you do the MyOpen Math. Now, Elle asked if she could use the calculator and cheat on the MyOpen Math. You can, but on my test, you have to show the work. So you can check it with the calculator, but you got to show the work to verify that it works algebraically. So what I'm going to do is I'm going to take my equation right here, and I'm going to replace y with what? What am I replacing it with? Negative y. So I'm going to go x minus 2 squared plus negative y squared is equal to 1. And what I'm going to do is I'm going to simplify this equation. And if I simplify this, if it's equivalent to the original, which means if I can simplify this and I can get back to the original, it's symmetric to that, whatever we're testing for. So what happens when you square a negative? So x minus 2 squared stays the same. If I square negative y, it becomes positive y squared. My question is this the same as the original equation? Is that exactly the same as the original? So then the answer is yes, it is symmetric to the x-axis. That means every point below has to match up with every point above. So for example, if I had the point 2, 3, I'd have to have the point 2, negative 3. You tracking? If I have the point 0, 5, I'd have to have the point 0, negative 5. Like those points have to match up. You have to be able to reflect across and find a point in the same location. All right, y-axis, what do you test for? What do you got to replace? Negative x. So I'm going to plug it into the original equation. So I'm going to have negative x, now this one's a little tricky, squared plus y squared is equal to 1. Now you might have to do a little work to see if this is true. Okay, everything, the y squared is fine. I'm going to write the original equation down right here. It was x minus 2 squared plus y squared equals 1, correct? I'm going to call the original equation. Is it okay if I call it the OG, original gangster? Okay, so the original equation is always the OG for us. Okay, is this the original equation? All right, let's compare it. Can I make this, when I plugged in a negative x, can I make it look like the original? Well, this is tricky here because you put in a negative x, but you can't square the negative x. Why? Like the last one, you could square the negative y. Why can I not square the negative x? Because it's glued with the negative 2 now. Okay, orders of operations. But what I can do, now watch what I'm about to do. I can take a negative out of this. I'm going to take the negative out. That'll leave me with x plus 2. All of this squared. So I took that negative out. Does everybody see what I did? Now you can square the negative and get rid of it. What happens when you square a negative? Becomes positive. So now I'm left with x plus 2 squared because I squared the negative. I took the negative out so I could square it. Do you see what I did there? Plus y squared is equal to 1. All right, I got rid of the negative. Is this equivalent to the original? Is that the same as the original equation? No, why not? It says x plus 2 instead of what? So this is a big no. Now I'm going to go ahead and give you a hint. The only way it's ever symmetric to the origin, okay, the only way it's ever symmetric to the origin is either both of these have to be yes, okay, or it's not going to be symmetric to the origin, because when I replace negative x and negative y, you're going to run into the same problem with, if you weren't able to get rid of the negative on one of them, you're not going to be able to get rid of it when you do the origin. So when you plug in negative x here, you'll have negative x minus 2 squared, and you plug in negative y because you do both here. You do negative x and negative y. The thing is, I can get rid of the negative on the y squared, can't you? And I can get rid of the negative on the x, but you had to factor it out, so does it change the equation? Yeah, because when you took the negative out, it was x plus 2. You're able to get rid of the negative on the y, and you're able to get rid of the negative here, but it changes the equation and makes it x plus 2 squared. And this is not equivalent to the original, so then the origin is also no. So what's the only thing it's symmetric to? The x-axis. It's not symmetric to the... So I know I'm going to be able to fold it. So here's what I can do. I can graph this now. So I'm going to create a graph here. I don't know where you got white space, but I got white space right here. So I know I've got a point 3, 0, and 1, 0. So I've got a point at 1, 0, and I've got a point at 3, 0. And I know I'm symmetric. I should be able to fold it across the x-axis and everything match up exactly. But here's the problem. I don't have any other points. I do not have any other points, so I need to get another point. What would be a logical point to plug in? I'd plug in 2 and see what happens. Let's plug in 2 for x and see what happens. So why don't you do that real quick and see what happens. If I plug a 2 in for x, so we're going to do x equals 2. Let's see what happens when I plug in 2. If I plug in 2, I'm going to get 2 minus 2 squared plus y squared is equal to 1. What's 2 minus 2? 0. What's 0 squared? Yep. And you get y squared is equal to 1. The 0 you can just drop off, can't you? Now what do you do? Square root of both sides. What happens if you take the square root of both sides? Plus or minus 1. Square root of 1 is plus or minus 1. Okay? So that means I'm going to have 2 points. What are they going to be?
Negative and positive 1.
Yeah, so, but what's the x value? So look up here. You had y, and I'll show this. It's y squared equals 1. You took the square root of both sides, and we got y equals plus or minus 1. So what is it?
2.
2, 1, and what? 2, negative 1. You get the point 2, 1, and 2, negative 1. You tracking? Is everybody okay with that? Keithan, good?
Yeah, I'm good.
Okay. So if I go plot this, I get 2, 1, and 2, negative 1. What do you think this is? It has to be symmetric about the x-axis. What do you think this graph is? If you had to take a guess.
Diamond.
Maybe?
Rhombus.
I would say probably it's a circle. Okay, because we assume it's curved. We don't assume it's going to be straight lines. Because the only way I could get straight lines if they were just regular x's, but they're x squareds, and x squareds are curved like parabolas. So, and y squareds are curved. So you're going to get, it's going to look like this. And it's symmetric to the x-axis, so it's got to be perfect. Now you might guess rhombus if we had plus or minus y's and plus or minus x's. But we got x squareds and y squared, so I know it has to be curved. Yes?
Okay, so if we have done the y-axis, and the x-axis, like, and showed that one of them is not symmetric, do we still have to, like, do the origin too?
You just need to be able to say no. You need to be able to memorize it. And if you're unsure, then do the test. If you know, if you can remember that, hey, it's a symmetric to the x, but not symmetric to the y, then I know the origin is going to be no. Fine, you don't have to show any work for the origin. But if you're unsure, do the work. Okay. I'm not going to have you do a ton of graphing by hand. I just don't see, like, I just want you to be able to get the x and y intercept, do the tests. If I asked you to generate a graph without a calculator, I'd probably do it for extra credit. Okay, because sometimes you have to actually plot a lot of points to figure out what actually is going on. This one was pretty easy. Question?
After you did the y equals plus or minus 1, how did you get those 2 points?
So I knew x was equal to 2. So it was 2, 1, and 2, negative 1. So that 2 was giving y equals plus or minus 1. So that creates 2 points, 2, 1, and 2, negative 1. Does that make sense?
Wait, why'd you pick 2 though?
I say, if you were to try
Because it's
it
in
with a
between
different
those.
number, would it?
You could have done it with a different number. Maybe you do. If you do numbers over here, I bet, let's try a different number. Let's say you tried, well, we already did 0 earlier. Remember we did 0 for the y-intercept? What did 0 give us? We plugged in 0 earlier. What did 0 give us?
-3.
It gave us the square root of -3, which is what kind of a number?
Imagine.
Imaginary numbers don't show up on our graph. So that's why there's nothing over here at 0. If I would have done, here's another one. Let's say I would have done 4. Let's say you go out to 4 and would have plugged in 4. Let's see what happens if you would have plugged in 4. I bet it's imaginary. All right, so here we go. We'll take the equation. We'll do x equals 4. Just watch. You don't even have to write this down. So it'd be 4 minus 2 squared plus y squared is equal to 1. What's 4 minus 2?
2,
What's 2 squared?
4.
4. Watch what's going to happen. So you're going to get 4 plus y squared is equal to 1. Subtract 4. What do you get again? A negative. Take square root of both sides. You're taking the square root of a negative. What's the square root of a negative? Imaginary. What do we do with imaginaries for right now? What did I tell you to do with imaginary numbers for right now? Throw them out. They don't show up on the graph. So, again, the graph part's going to be a little extra. If I have you do it, without a calculator, I'd let you have that for extra credit. Might be a good extra credit question to figure out what the graph looks like. All right. I think that's it for this section.
Let's go.
Yeah, there it is. Yep, let's go to 1.3. Actually, what I'd like to do is real quick, if you pull out your textbook and take a look at section 1.2. Everybody take a look at section 1.2 in the textbook for just a second, please. And go to the homework page. Go to the homework page. And I just want to do a problem just to make sure you're doing one. Can you pick one of those ones that you asked me about? Give me 2 problems to do. Like, give me one of the ones in the beginning where you had like variables like m and 2m and whatnot. What number was that in section 1.2? Yeah, 3 or 5. Give me number 5. What's 5 say?
N, 4 minus 2n squared.
N comma 4?
Yeah.
Like comma?
Yeah.
Oh, it's an ordered pair. Okay, n comma and then what? 4 minus n squared?
Yeah.
All right. And then such that, and then what'd they give you?
N is equal to 0.
Yeah, here's a good problem to look at. I have some problems like this on the test. So this is a relation. So this is not going to be a number line. So when they're saying the graph of ordered pairs, now we're plotting in the XY axis. So we're actually trying to figure out plots of points. So this assignment 1.2, section 1.1, listen to me. Section 1.1, everything was on a number line because it was just one variable. It was just figure out the set of all numbers X, the set of all numbers Y. But this is a set of all numbers X comma Y. So these are ordered pairs. So you know you're going to be plotting it in the coordinate plane. Okay. So here's what you do. They tell you that n is equal to 0, plus or minus 1, plus or minus 2. So how many points are there? Close. Got plus or minus 1, plus or minus 2. So there's actually just 0. 5 points. There you go. So you got n equals 0. You got n equals 1. You got n equals negative 1. You got n equals 2. And you got n equals negative 2. You need to figure out, plug this in. So these are the n values. The n's are the x's. What are the y's? How do you calculate the y's?
Put the numbers in for n.
4 minus n squared. Put the numbers in for n in that equation. So the x's, these are the x's. The y's are calculated by going 4 minus n squared. So you're going to have to take each one of those n values and plug it into my equation, 4 minus n squared. So we're going to have 4 minus 0 squared. You're going to have 4 minus 1 squared. You're going to have 4 minus negative 1 squared. You're going to have 4 minus 2 squared. You're going to have 4 minus negative, minus, and they have this on my open math, I believe, too. Negative 2 squared. So what's 4 minus 0 squared? 4. So that's going to give us the point 0.04. Because remember, this is the x's, the n's are the x's, the 4 minus n squared are the y's. That's what forms your points. What's the next one going to be? What's 4 minus 1 squared? 3. So that'll be the point 1 comma 3. All right, now go to n equals negative 1. What is that going to give you? What's negative 1 squared? What's 4 minus 1 again? 3. So that's going to give you the same thing. So it's going to be negative 1, 3. What's the next one going to be? 0. You better pay attention and make sure you know how to do this. What's the next one going to be? Negative 2 squared is also 4, so that'll also be 0. So you're going to have 2, 0, and negative 2, 0. So what they asked you to plot here was 5 distinct points. We call this a discrete relation. It's not continuous. I just wanted these 5 x values. That's it. So all you do is go to your graph and just plot those 5 points. So that's one of the easier ones. I think the first like 5 or 6 problems in the assignment are like this. You just plot points. So you got 0, 4, 1, 2, 3. You don't even connect them. It's not a continuous function. You got 1, 3, 1, and negative 1, 3. And then you get 2, 0, and negative 2, 0. And that's it. You just plot those 5 points. They just want you to plot those specific 5 points. Or give me a harder one, though, now. One that's like an inequality or some shading. Give me a goofy one. 20. All right, 20. Okay, number 20. Ooh, that's really good. You picked a great one. Okay, number 20. And if you don't go through and practice these, you're going to struggle with this. X comma Y. And I think you need to practice a lot of these to get it, because this is something, the reason I gave a lot, I don't usually give this many in the homework because you're already doing my open math, but these I really think you need to practice and go through. So if you haven't taken the time to do all these, you need to do them, because this is pretty foreign. You haven't done stuff like this before. I can't say, oh, you did this in 9th grade, because you didn't. I can't say you did this in pre-calc because you didn't. Okay? This is pretty new for you guys, so you need to practice this. All right, so again, they're wanting you to graph ordered pairs. How do I know? Because they said the set of all numbers X and Y. See, section 1.1, they were only doing this. Section 1.1, if you go back to that homework, hopefully you did all 20 of those when I gave a lot of skill and kill. Okay, section 1.1, it was just the set of all numbers X. So that you do on a number line. Or it was the set of all numbers P. Or the set of all numbers Y. That you just do on a number line when it's just one variable. Everybody, one variable you do on a what? 2 variables you do in a what? A graph, a coordinate plane. Okay, you do it in the XY coordinate plane. So I want to come up with this, and here's what they tell us. They tell me the X values are between negative 2 and what? 2/3. This is like -2, a bracket, -2, comma, 2/3 bracket. You don't have to do this. Union, all right, sorry, that would be the x's. So that'd be the x's. The y's, so this would be the x's. Okay, it's from -2 to 2/3. The y's would be from what? It's from pi to what? 9/2. That's the y value. So what I want is I want the x's and the y's, all my x's to be satisfied according to this, and all my y's to be satisfied according to this. All right, it's a little tricky. How am I going to do this? Well, can x equal -2? Is x allowed to equal -2? Is x allowed to equal 2/3? Here's what I'm going to do. I'm going to say, watch this. Okay, this is where this one's really weird. It's not that bad. You have done this kind of thing before, but not like in this notation. It's definitely different than what you did in ninth grade. Way different. Okay, you've done, when I do this in a second, you're going to be like, oh yeah, I remember shading and all that stuff. All right, so we're going to go -2. Now, if it's x equals, what did I say last Friday is an x equal equation? When you have x equal to a number, what kind of graph is that? We went over this on Friday. What kind is x equals a number? What kind of graph is it? A vertical line. So we got a vertical line at x equals -2. Is it solid or dashed? It is solid. And then we've got one at 2/3. So let's put 2/3 right here. This is 1. This is -2. This is -1. So then we got a solid line at 2/3, a solid vertical line at 2/3. And it's solid line because it's brackets. And x is going to be everything in between there. So in a minute, we're going to shade. So I'll shade real quick just so you can see. X would be everything in between there, including everything at -2 and everything at -2/3. But is y allowed to be anything? Don't shade yet. Is y allowed to be anything? No. Y is not allowed to be anything. What does y have to be between? So we're going to take this red shaded region and we're going to throw some y's out. We're only going to keep the y's that are between what? Pi and 9/2. Where's pi going to be? And what kind of line is it if it's just y equals? Hold on. What kind of line is if it's just y equals a number? Horizontal line. Now we're going to have some solid or dashed, okay? So let's go to pi. Let's go to pi first. What is pi? 3.14. So let's go up to pi. So let's see. 1, 2, 3. So 3.14. What kind of line is that going to be? Why is that one dashed? Because it's open. All the points are open. So we use a dashed line to represent an infinite number of open points. Because we're saying it's not included. All right, where's 9/2 go? Where does 9/2 go? 4.5? Yeah, 4.5. And what kind of line is that going to be? That'll be a solid line at 4.5. All right. Now, y is going to be everything between that. Now, here's what I would do. Some people like to shade over top. I don't like to do it. I like to say, okay, x is going to be everything between the two vertical lines. So here's what I'm going to do. I'm going to draw some arrows. I actually don't shade until I know for sure where it's at. I know x is going to be everything between this vertical line. I'm going to draw some arrows here. And this vertical line. Are you with me there? Does everybody agree? X is going to be between those two vertical lines. What's y going to be between?
The dashed one.
Does everybody agree with that? Where do they overlap? Where are they all going to be true? That rectangle in the middle is where they're all pointing to each other, where we're going to satisfy all the x's and we're going to satisfy all the y's. So the final answer is just this right here. You got to look for where the overlap happens. You need to practice that, I'm telling you. Okay? Does that help? That's one of the harder ones. That's probably one of the hardest ones. Okay? But if you can handle that, I do have one of those on the test.
So how do you know when you're supposed to like shade or whatever?
Usually you shade when you got an inequality, if it's not an equal to.
Okay.
Yeah, there's usually going to be some kind of shading because you're talking about it's between some values. So you got to capture everything in between. So you got to shade when it's that. When you got less than or equal to or greater than or equal to, there's almost always shading when you're graphing in the coordinate plane. Okay, so when you're graphing in the coordinate plane and you got greater thans and less thans and stuff like that, you got to capture a big range of values. So you got to do some shading. On a number line, you just drew an arrow one direction. You didn't have to shade. That was kind of the shading, was just like an arrow going this way. You were either doing, that's why it's easier. When everybody's on a number line, they're like, it's no big deal. It's just like, oh, I just go this way.
Yeah.
That's like shading in 2 dimensions. Or it was between these two values. Or it went this way. Okay, but in the coordinate plane, when you have less than or equal to and greater than or equal to, there's always going to be some shading. Okay, does that help?
Yeah.
Okay, go to 1.3. Let's get that started. And then this is an easy section. Probably the easiest. I might even be able to finish. I don't know, I've only got 12 minutes, but there's not a lot here. This will be a light section for you. The MyOpen Math will go quick. You'll remember most of the stuff from 9th grade and pre-calc. For sure from pre-calc, because you did so much of it. You did domain. How many of you remember domain and range from last year?
Yeah.
Okay, recall it. And testing whether or not something's a function, super easy. Okay, we're getting past the dry stuff. Okay, we're getting close. This first chapter is just kind of terrible. You just got to bear with it. All right, so first thing, a relation, definition, a relation. I don't know what page this is on in the textbook. Can anybody tell me what page it is? 43, page 43 in the textbook's where we're at. A relation in which each x coordinate is matched up with only one y coordinate. In 9th grade, I said the x's couldn't cheat. So if you had me as a 9th grader, the x's can't cheat. The x can only have one date to the prom. Now, I didn't say anything about the y. The y can roll up with multiple dates. Okay? So if Addie wants to carry 5 guys, if she wants to have 5 guys in her arms going to the prom, she can, but she's probably not going to. But if she wanted to, she could. Okay? But the x, if I pretend the x's are the guys, you can only have one date to the prom, Brody. Okay? Trust me. Probably a good idea. All right, a relation. One's enough. All right, a relation in which the x coordinate is matched up with only one y coordinate is said to be a function. So a relation, remember, we said is a set of ordered pairs. We just said a relation is just a set of x's and y's. It's just a list of ordered pairs. And sometimes we can have a set of ordered pairs where we can actually count how many they are. We said that's discrete. And then when you have an infinite number of ordered pairs, we call that continuous. And that's usually when you get a graph. You connect all the points, you get a line or a curve. Now, when you have a relation, when you have all these x's and y's, if the x's are matched up with only one, please circle only one. That's the most important part. When they're matched up with only one y value, it's said to be a function. Now the relationship is special. It's functional. Okay? Your prom date's not going to get mad because you only asked her, Brody. Okay? So the relation is a function as long as you only ask one date to the prom. If you ask 5 different people and you get 5 yeses, you're going to be in trouble. All right, look at these. A and B. Are there any cheaters? X is all that matter. Don't care about Y. Honey Badger, don't care.
Yeah.
Which one is a function? Which one is not? Or are they both functions?
R1 isn't and R2 is.
R1 is not a function. Why is R1 not a function?
There's one in there.
Because the 1 is cheating. Do you see how the 1 is paired with a 3 and with a 4? The 1 cheats. What about R2? Is that a function? Yes, because none of the x's are cheating. -2, 1, 2, 3, those are all good. Simple. Just make sure the x's aren't cheating. Now, when you look at a graph, does anybody know how? I do it when you look at a graph. There's a test you use from 9th grade. The vertical line test. Very good, Brody. If you take a vertical line, that vertical line represents one x value. Remember, x equals a number is a vertical line. Do you agree? So right here, this is x equals -2. What this vertical line is showing that the vertical line has every y value represented on it. So at -2, is every y value on that vertical line represented? Yep, up forever, down forever. Do you agree? But if you only cross the graph once, then you know that x only is paired with how many y's for that function. So if this vertical line only crosses it once, how many y's is it paired with? How many dates to the prom does it have? And no, right, this vertical line is the infinite, but when I actually cross it with this graph only has what? One date to the prom. Right here, it's got what?
2.
That's where it's a problem. That's not a function. So if the vertical line ever intersects it more than once, it's not a function. If it only intersects it once, it is a function. Does that make sense? Okay, pretty straightforward. So the vertical line test. A set of points in the plane represents y as a function of x if and only if no 2 points lie on the same vertical line. So that's what the vertical line test concludes. Just make sure. So let's just look at this real quick. Couple examples here. Okay, I'll take a vertical line. You tell me, does it pass the vertical line test? Does R here pass the vertical line test?
No.
Clearly not. And you only have to find one place where it doesn't work. Now, this not only have one place it doesn't work, it has a lot of places where it doesn't work. So this is definitely not a function because you can find a place where the vertical line is going to cross it more than once. What about graph S?
That's good.
It's good. It is a function. Okay? Any questions? All right, that's pretty simple. Let's see about this one. Okay, this is a little interesting. So they make it a little more complicated by doing some open and closed points. So let's clarify here. So this parabola, look so far. Is it passing the vertical line test? Is it only crossing in one point? But when we get to the point 1, my question is it crossing once or twice?
Twice.
It is crossing twice because there's a point here and there's a point where? Remember, if you have a connected graph, is it points? It's a set of infinite points. You don't see the points because all the points get what?
They're in the line.
They're in the line. They're connected. When you have all those points, it fills in all the gaps and they're all connected. And that's what forms the line or the curve. Okay, but over here, if I go to the next one, okay, so that one does. S is a function. Yes, we'll put yes by it. But this next one is this one. Sorry, I screwed that up.
Yeah.
Not a function. Yes, it does not pass the vertical line test, so it's not a function. I don't know why I said that backwards. That's weird. So not a function because it intersects it more than once. Yes, it intersects it more than once, so it's not a function. Now the next one, does it intersect it more than once? Everything looks good, but then at 1, you've got to ask yourself, is it intersecting it more than once? No, why?
Because it's open.
Because it's open at one of those points. So it only intersects it at the closed point because there's nothing at the open point. The open point means there's nothing there. There's a hole there. There doesn't nothing there. So this is a function. So this one, yes, it passes. It does pass the vertical line test. The last one did not pass the vertical line test, and therefore, since it intersected the graph more than once, it was not a function. So S1 is not a function. S2 is. All right, domain. Is everybody familiar with domain range? This is really the last thing. I can get this done. Domain is the set of all what? X coordinates. So suppose F is a relation, a set of ordered pairs, which describes y as a function of x. In other words, it passes the vertical line test. So we have a function. Keithan, we have a function. It passes the vertical line test. So if we have a function, then you can find the domain. The domain is the set of all what?
X coordinates.
Now I'm going to call those inputs. Everybody say input. And I want you to think of this because when we get to functional notation tomorrow, I want you to think of inputs as what you put in the machine. Okay? The function is the machine. Think of the function as a vending machine. When you walk up to the vending machine, you got to put something in. What do you put into a vending machine?
The input.
Money.
The input. What do you put into a vending machine? What can you put into a vending machine? What are you allowed to pay with in a vending machine? Money? What kind of money?
Quarters.
Quarters? What kind of cash? Can you just put any kind of cash? I can put a $100 bill in a vending machine and it'll work.
No.
No. What kind of cash can I put in? $1, $5, 10s, 20s usually work at most vending machines. They give you a lot of quarters back. I did that one time and I got $19 back in quarters. I actually thought I put a $1 bill in. So later that day I told Miss Tossinson, I was like, I hit the jackpot. The vending machine gave me all these quarters back and it gave me my drink. It messed up. And then later that day I went to pay for gas and I went to go in. This is like 15 years ago when gas was a lot cheaper. I had a $20 bill. And I was like, where'd my 20 go? I had $19 in quarters.
Did
So
you
I put a
pay for
20
gas
into the
first?
vending machine, and I didn't realize, so then I had to go back to Miss Dawson and said, remember when I told you the vending machine gave me a bunch of quarters? It didn't. I put a $20 bill in by accident, and it gave me $19 back. So 1 works, 5s work, 10s work, 20s work. Do pennies work in a vending machine? No, so it's not in the domain. Do nickels work?
Yeah.
Yeah, nickels work, dimes work, quarters work. 50-cent pieces and silver dollars probably don't work in a vending machine. Do credit cards work on vending machines?
Yeah.
Some. That would be your domain, is what's allowed to be plugged into the vending machine. What is the range? 3 minutes here. What's the range? Y coordinates. What do you think we're going to call the range? It's what comes out of the vending machine. So after you put your money in and you select, what comes out of the vending machine is the output. Maybe it's candy, maybe it's pop, maybe it's coffee, maybe it's, I don't know, whatever. So real quick, we'll end with this, and I'll pick up here tomorrow. Find the domain and range, and I'm going to wait on bookwork. I'll sign some bookwork tomorrow so you don't have to worry about it, so some of you can get caught up from being gone. Okay, find the domain and range of the function. Real quick, what would the and we're going to write it like this, domain, and we're going to say the set of all numbers x such that, and then you're just going to list the x values. So what would the domain be here? What is it? -3, 0, 4, 5. Okay, there it is. Just list the x values.
Do we have to write it like, that form with the X such that?
You can just do the braces and just list the x's. Okay, the set of all y's such that, what's the y values here? 1 and 2. Do you have to list the 2 more than once? Is it okay that the girls has more dates to the prom? Which one did I say can't cheat? The x's can't cheat. Are any x's cheating? No. Okay. All right, so this is the domain and range of this. Now, the graph of G, that was F. That was graph F. So this was the domain and range for F. Let me end with this. G, this domain and range, it's not a discrete function, it's a continuous. So how do you write the domain and range for G? I'll do this one in blue. It's going to be a range. You're going to have to use inequalities. So you're going to have to say the set of all numbers x such that. How are you going to do this? Except what? You can only go up to what?
4?
Up to 1. I'll have to do more of this tomorrow. It's actually going to be x is less than 1, or you can do negative infinity up to 1 parentheses. We're going to have to review that. And then the range, does anybody know what the range would be real quick? It'd be y less than 4, or you could go negative infinity up to 4. Oh, that'd be brackets, be less than or equal to, because you can touch it. I'll go over plenty of those tomorrow, don't worry. So, focus on getting any bookwork done you didn't get done last week and start getting my open math done. So no